This ShowMe is an overview and review of how to write the equations of lines under certain conditions. It's designed for an Algebra 2 student who should have already seen most of this before, but needs a refresher. Talk briefly about how to use slope-intercept form of a line to write the equation of a line, how to use point-slope form, how to find the equation of a line when you're given 2 points, how to find the equation of a parallel line given a point not on a given line, how to find a line perpendicular to a given line through a given point, how to use slope-intercept models in solving word problems, and how to use standard form models to set up word problems. If you are given that the slope of a line is m, and the y-intercept is the point 0b, remember that y-intercepts are on the y-axis, the x-coordinate will always be 0. The equation is y equals mx plus b. Filling in our table down the line then, y equals 1x plus 1. Note that when the slope is 1, you don't have to write it. If you see an equation of a line written this way, people will expect you to know that the slope is 1. Similarly, when the slope is negative 1, here the equation is going to be y equals the opposite of x minus 2. The slope is negative 1. You don't write the 1 usually. If you see minus x, you're supposed to know that the slope is negative 1. Note also that we did not write plus negative 2. We just went ahead and used the definition of subtraction. But you're supposed to know that the intercept, when you see that, is negative 2. Continuing then, for the next one we have y equals 2x minus 3. Slope is 2, the intercept is negative 3. Then y equals negative 3x plus 4. It's probably all very comfortable right now. A couple things to remember. A lot of the time slope is expressed as a fraction. That's actually very convenient because the slope is a ratio by definition. So y equals 1/2 x minus 5. This is perfectly acceptable. You'll see that a lot. Note also that when slope comes out to be an improper fraction, as in the last example, negative 4/3, we don't write it as negative 1 1/3 usually. Write it as negative 4/3. Slope is a ratio, and writing ratios as improper fractions is generally more improper than writing them with mixed numbers. Note also that your intercept can be a fraction, and that will happen, and that's okay. In fact, it's very common for that to happen. So there's a brief overview of how to use slope-intercept form. When you have information that consists of a slope and a point that's not a y-intercept, you can still write the equation of the line rather quickly using what's called point-slope form. Point-slope form is y minus y1, where y1 is a given value for y, equals m times the quantity x minus x1, where x1 is the x-coordinate that goes with y1. Note that x1 and y1 have to come from a point on the line, so you have to have at least that much information to use this. Doing this then, you have y here for the first one, y minus 3. Your y1 value is 3. Your slope is 1. Again, you don't have to write that. You could, but you don't have to. And then x minus 2. The reason you probably would write the slope here is that point-slope form is rarely your destination. If you're going to graph the equation, you probably want to go to slope-intercept form. If you're going to do anything involving matrices, you're probably going to go to standard form. But point-slope form is a great place to begin when you have this information, and it's relatively common that you will have this information. For the next example then, I have y minus 4 equals negative 1 times the quantity x minus negative 3, but subtracting negative 3 is the same thing as adding positive 3. When you see that plus 3, if you ever encounter this form of the equation, it would be expected that you would know that that actually represents minus negative 3. You should be familiar with the formula given up here at the top. For the third example, y minus negative 5 would be y plus 5 equals negative 4 times the quantity x minus 4. Again, that plus 5 with the y comes from the fact that we're subtracting negative 5. And when you subtract a negative, that looks like addition. For the fourth example, we have y plus 6 equals 8 times the quantity x plus 5. That happens because, in this case, both of our coordinates for our given point happen to be negative. And so you'll see a bunch of pluses, but you have to remember that indicates that we're subtracting a negative, not really that we're adding anything. For the fifth example, remember your slopes are often going to be fractions. We have y minus 7 equals 4/5 times the quantity x minus 1. And finally, on the last example, things can be negative or positive everywhere. We have y minus 3/5, they can also be fractions, and that's okay, equals negative 7/6 times the quantity x plus 2. Again, plus 2 because the coordinate given to us is negative and we're subtracting. So that's an overview of how to use point-slope form when that's the information that you have. And probably this is the most common entry point into working with a linear equation in two variables from given information. So what if you have two data points and you want to find a line through both points? Here's how it's done. The first information you need after you've got the coordinates of the 2 points is the slope. And slope is found by taking the ratio of the change in y, or y2 minus y1, over the change in x, which is x2 minus x1. Then for your equation, you use point-slope form. Now I'm going to write y minus y1 equals m times the quantity x minus x1. But please note, you don't have to use just x1, y1. You could just as easily use x2, y2. The only real stipulation is that x1, y1 has to be a point on the line. So I could end up using either of those points, and I will probably in these examples. Alright, for the very first problem then, the first thing we need is a slope. So, slope is y2 minus y1, should be 4 minus 2 on top, over x2 minus x1, which would be 3 minus 1 on the bottom. 4 minus 2 is 2, 3 minus 1 is also 2. The slope of this line is 1. We're getting a little crowded on information here, so we'll put in a column line, make sure we don't get things too mixed up. For the equation then, y minus, and again I can use either point, I'll go ahead and use x2, y2, y minus 4, so I've used this y coordinate, equals our slope, which we found to be 2, times the quantity x minus, in this case has to be 3, again, x1 and y1, whatever we're using in this equation, they have to come from the same point on the line. Now remember what I've said before about point-slope form. It's a starting point. Generally you won't be stopping here, you'll be going on to the slope-intercept form so you can graph it easily, or you'll be going on to standard form so that you can work with a matrix or some other operation. So don't expect to stay with this form, but this is a great place to begin your work with the algebra side of a line. For the second example, the slope is going to be 5 minus negative 3 on top, which is 8. So 5 minus negative 3 is 8. On the bottom, 4 minus 2, which is 2. Our slope is going to be 4. So we have y plus 3. I'm going to go ahead and use the first point this time. Y plus 3 equals our slope 4 times x minus 2. Again, remember, if y is negative 3 for my y value, I've got to use 2 for my x value. They have to come from the same point. It's easier to get confused and mess that up now that you have 2 points to look at. Make sure you indicate which one you're using, maybe by circling it in your work. Remember to mark up your work. Teachers love that. They can see how you're thinking, and they can help you modify that so that you can be more successful. For the third example, the slope is going to be 6 minus 4 on top, which is 2, and 5 minus negative 3 on the bottom, which is 8. So our slope is a positive 1/4. So we have y, and I'm going to go ahead and use 5 and 6 this time. I generally prefer to use the positive numbers. It's less confusing for me. Y minus 6 equals 1/4 times the quantity x minus 5. Do remember, it doesn't matter which point you use. Either one is on the line. Either one will give you the same results when you shift over to standard form or to slope-intercept form. For the fourth example, slope is going to be negative 7 minus negative 5, which is negative 2 on top, and then 6 minus negative 4 on the bottom, which is positive 10. So have a slope of negative 1/5. So we're going to have y. Now, almost everything is negative here. I'll go ahead and prefer to use 6 negative 7, because at least part of that isn't negative. But the negative 7 is, so I have y plus 7 on this side, equals negative 1/5 times the quantity, x minus 6. For our last example, I included this one because this sort of thing shows up in word problems sometimes. And if you get flustered with word problems, you want to run home to mama, something that's consistent and easy to use. And for me, that's point-slope form always. To find the slope is still the same process. It's a little easier with all these zeros. On top, you're going to have 5 minus 0, which is 5. On the bottom, 0 minus 3, which is negative 3. So the slope of that line is negative 5/3. So for your equation, you have y. Well, you see now, I wouldn't even use point-slope form here, to be honest. This is the y-intercept. You should be able to recognize that. Anything that's on the y-axis has an x-coordinate of 0. So I wouldn't use point-slope form here. I would use slope-intercept form. I have a slope, y equals negative 5/3 x, plus the y-intercept, which is 5. Okay, so notice that you wouldn't always run home to mama. Sometimes slope-intercept form is right there in front of you. Always best to go there first if you can. The reason that problems that involve 2 points sometimes are more difficult is that you can't run to slope-intercept form right away. It's not as simple. So there's an overview of how to solve a situation, how to get yourself the equation of a line when all the information that you have is just the 2 points. And in most cases anyway, they don't happen to be the y-intercept. Here's a problem that sometimes gives students trouble. Find the equation of a line parallel to a line through the point in a given point. Well, this particular line needs a little bit of work. 3x plus 2y equals 1 is in what we call standard form. In standard form, the slope is always negative a over b, given that a is 3, b is 2, and c is 1. So the slope of this line is going to be negative 3 over 2. Now that we have a slope and a point, understand that parallel lines always have the same slope. So even though this line that we're going to is not the same as the line we have, it's going to have the same slope. Now, where do we go from here? We should go to point-slope form. Y minus y1 equals m times the quantity x minus x1. When doing homework, it's for practice. I recommend that you write the formula every time you use it. When you're taking the ACT or you're under pressure in class, maybe you won't do that. But on homework, when you need to be taking your time and making sure that you've got all the concepts down, writing formulas is a great way to make sure that you're on track. It also gives your teacher a clue as to where you may or may not be going wrong. Okay, the next step is to fill in from the information you've got. Y minus 5 for y1 equals, our slope is negative 3/2, then the quantity x plus 2. Now, under these conditions, it might be that you're expected to produce a line in similar form to the one you were given. If that's the case, you just have a little bit of algebra to do. You got y minus 5 equals negative 3/2 x minus 3. Here we apply the distributive property on the right side. And then to get standard form, x has to be on the left side. Add 3/2 x to both sides. And all the constants have to be on the right side, so add 5 to both sides. And here you're in standard form. Often people prefer standard form to be integers. That's easily managed by multiplying everything by the denominators. In this case, the only denominator is 2. Multiply everything by 2, you have 3x plus 2y equals 4. Notice that 3x plus 2y appears in both places. Remember, they're parallel lines. They have to have the same slope. That also clues you in. Whenever you see two equations in standard form and x and y have the same coefficients, that means those lines are parallel and will not ever intersect. Like the previous problem, it's common for textbooks, exercise writers to have students go through the practice of finding the equation of a line perpendicular to a given line through a given point. As before, our equation needs a little touch-up. We got negative 3x plus 5y equals negative 2. The slope for such an equation is always negative a over b. And the opposite of a in this case would be positive 3, and b is 5. So the slope of the line we're given is 3/5. However, we're not interested in that slope particularly. We're interested in the slope of a line that's perpendicular to that. Perpendicular lines have slopes that have a product of negative 1. The effect of this is to find the slope of a line perpendicular to a given line. We take the reciprocal of the slope we know, and then take the opposite of it, what is often referred to as a negative reciprocal. And that's what I'm going to call it. The slope of our perpendicular line then is going to be negative 5/3. This is the slope we want to use in our equation as we get our answer. Now that we have a slope and a point, it's time to use point-slope form. Y minus y1 equals m times the quantity x minus x1. So we have y minus 7, that's x1, equals m, our slope is negative 5/3. And then inside the parentheses, x minus negative 4, which is x plus 4. As before, this is rarely where you stop. Let's clear the fraction, multiply everything by 3. So we have 3y minus 21 equals, now I've cleared the 3, I'll also go ahead and clear the parentheses, take negative 5 times x, and negative 5 times 4, which is negative 20. X and y should be on the same side to get standard form. So we're going to have 5x plus 3y. That's adding 5x to both sides. And then add 21 to both sides to get this. Notice that with perpendicular lines, the coefficients of x and y will be switched in terms of their absolute value, and then one of them will have a change in its sign. Doesn't really matter which one, but notice they're negative reciprocals, so these numbers get switched around. Notice the numbers stay the same when the lines are parallel. They get switched around, and one of the signs changes in a perpendicular line. That way you can kind of pick those out when they happen. That may matter in the future. Slope-intercept models show up in more places than just in math class. When you go to science class, you may have to fit lines to data. You may have to use a scientific calculator to do regression models. Slope-intercept models generally provide for a rate of change and an initial value. So you could have y equals, and instead of having what is called a slope, it still is a slope mathematically, but it may represent something else. A rate of change times x plus an initial value. Now this shows up in science classes when you start with data. You have a first value for your independent variable and you plug it in. The first number that comes in there, perhaps your independent variable is time. The initial value of what you're observing then is going to be the y-intercept for the graph that results in your lab write-up. The rate of change that you're going to measure is going from your data, which would be the coordinate of x in a regression model. That's going to be the slope of the equation when you go to do your graphs for your lab write-up. Of course, this also shows up in business. In business, let's say you hire someone to work for you. They're going to cost something just to show up. Just their fee for being there. If you hop into a taxi, they flip the meter. You immediately owe them some money just for getting in the taxi. That's why you generally check your destinations and everything before you get in. Once you're in, you owe the cabbie something for the time you're in the cab. If the plumber shows up, the plumber charges a fee just to come out to your house. There is a cost involved, and if the plumber chooses to charge that and you need the plumber's services, you're going to pay it. The rate of change, then, would be the price per unit of service. So the price per unit will be your rate of change, and that will imply the cost that somebody owes. Note that when you go to a store and you want to buy a product, your show-up fee is free. No one charged you any money for the store to be there. but it also usually means a relatively higher price per unit because the grocer or the store owner expects to be paid for keeping the lights on and having the store being there. In any case, these are very common in word problems. Also in lab write-ups, initial values and rates of change. So be open to that. All of these things are simply code words for slope, in the case of price per unit, or rate of change, and y-intercept, in the case of initial value, or the show-up fee. So keep that in mind when you're reading word problems. You need to be able to comprehend them and reorganize the information quickly into slope-intercept form. In some word problems, using standard form makes a lot more sense. An example of this would be a situation where there are choices involved between two products, in which case you may have a set amount of money to spend, and you may have two products you're considering buying, and you want to have some combination of the two products. Well then, the number of product X that you buy times its price will be one of the two add-ins involved in your purchase. The other one will be a price times the number of product Y. So for instance, if product X costs $3, you're going to buy a certain number of that, but you also want to buy as reasonably as much as you can of product Y, which costs $5, but you only have $20 to spend. You now have a line that is a border for your choice region on the plane. And in that region, you have choices to make. That region is going to look something like this. So you have a y-intercept of 4 and an x-intercept of 6 2/3. You get that by taking 20 divided by 5 to get 4. 20 divided by 3 to get 6 2/3. You obviously can't buy 2/3 of a product, but this is a border for a range. All of your possible purchases are inside the triangle. You obviously can't spend negative money or buy negative products, so the second, third, and fourth quadrants don't come into play. This is an example of a standard form word problem. But there are other examples also. It could be that you're selling something. Perhaps you're selling tickets to a show. This is a popular problem. We have a show where people can buy two kinds of tickets. You can buy the adult ticket for adults, and however many of those you sell, the product of that will be how much money you get from the adults. Of course, then that implies there's going to be a children's price, and you'll sell tickets to children, and this product will tell you how much money you got from children attending your show. This would be the money you got from the adults. Since all of your customers, all of your ticket holders are either adults or children, that would be the total amount of money you've made, or your revenue. And a favorite problem is to say, here's all this, here's the relationship between the number of adults and the number of children, and then you need to solve that. Okay. Well, the equation for your price model is most easily set up first in standard form. As always, these forms that you come to are entry points. That's a really long ShowMe, but it's meant to be a comprehensive review of the various ways we use the forms of written equations of lines, both to write the equations of the lines in order to get something to work with in the first place, and to solve and to set up some basic word problems that are very common in both the exercises and the assessments of these topics.